an incredibly rare and unusual type of crystal, once dismissed as impossible to exist, has been identified on a piece of meteorite in Russia. With a strange repeating structure, for years researchers believed quasar crystals could only be made artificially. Now the discovery, published in a new paper, marks the third finding of the bizarre materials in their natural form. The crystal, identified in a new paper published in Scientific Reports, was analyzed by researchers at the University of Florence, Caltech, and Princeton. The material came from a meteorite found in the Katika region of the Russian Far East 5 years ago. The team found a tiny sample of quasar crystal, just a few micrometers wide, after scanning the meteorite using scanning electron microscopy. The two examples of natural quasar crystal found previously were taken from the same meteorite, but were different patterns. The latest version features a kind of symmetry not seen naturally before, called icosahedral symmetry. This an exotic pattern featuring 60 points of rotational symmetry, made up of aluminium, copper and iron. What is encouraging is that we have already found 3 different types of quasar crystals in the same meteorite, and this new one has a chemical composition that has never been seen for a quasar crystal, author Paul Steinhardt from Princeton University, told Motherboard. Quasar crystals, short for quasi-periodic crystals, defy the symmetrical rules that define crystals. They are ordered, but not periodic. If you want to cover your bathroom floor, your tiles can be rectangles or triangles or squares or hexagons, said Patricia Thiel, a chemistry and materials science expert at Iowa State University. Any other simple shape won't work, because it will leave a gap. In a quasar crystal, imagine atoms are at the points of the objects you're using. Researchers discovered the first naturally formed quasar crystals in the early 2000s, after years of manufacturing artificial samples. Princeton physicist Paul Steinhardt and colleague Luca Bindi, from the University of Florence, found a grain of an aluminium, copper, and iron mineral with 5-fold symmetry. In 2015, Steinhardt and his team found a second quasar crystal. Now, 16 years later, the third specimen has been identified. Quasar crystals are a peculiar form of solid in which atoms are set in a non-periodic structure, said Dr. Bindi, who led the study. Up until a few years ago it was thought that these compounds could only be artificial, Dr. Bindi said.